Is that all right?
Oh, that's perfect. Okay, Björn,
Yeah,
let me introduce you. Good evening. We have our seminar of the Center for Institutional Studies at the HSU University in Moscow, and we're very pleased to welcome tonight as our speaker, Björn Brey, who is a PhD candidate from the University of Nottingham. He received his prior degrees from the same University of Nottingham and from the University of Constance. His fields are economic history, political economy, development, and international economics. And Björn's topic tonight is the long-run gains from the early adoption of electricity. Björn, our convention is to ask people to talk for about 45 minutes, if you please. People will be asking questions in the meantime in the chat column of the Zoom session, so please keep an eye on the chat. Or they can raise hands if you so wish. Feel free to decide yourself whether you would like to be interrupted in the process of your presentation or rather defer or all of the comments and questions until the end. So welcome, Björn. And let me remind everyone that we ask people to please identify yourself, register in the very same chat column of the Zoom session. And without further ado, Björn, the floor is yours.
Thank you, Leonid. Thank you, Bernardo, for the invitation. So yeah, feel free to ask questions as I go along because there's a lot of historical stuff in the data, and I'm happy to talk more about the details if there's some interest, because otherwise I might go a bit too quickly through them. So yes, as Leonid already introduced, this paper is titled "The Long-Run Gains from the Early Adoption of Electricity." And really what I try to understand in this paper is kind of what's the effect of adopting a new technology early on, and whether there are any gains that kind of persist over time within advanced countries. So you can think about it, areas that adopted the steam engine, for example, early, adopted electricity early, they had it for 20 years, but then it usually spreads quite quickly across an advanced country. Is there any gain from being an early adopter? So you can think of it as a first mover effect. And the motivation for this comes from the fact that there's quite a lot of evidence across countries in terms of the timing and intensity of technology adoption to be quite important in kind of driving the divergence in incomes across countries. But there's this kind of solo paradox, which was kind of phrased for IT, but it also applies for steam engines, electricity, and most general purpose technologies, that there's no positive effect really observable in aggregate data for most advanced countries. So we have this big technological breakthroughs, but for the first 20, 30 years, we actually see very little effect when we look at the aggregate statistics. So this might make you think, actually, because it's getting adopted very slowly, these technologies are not that efficiently used, then they might just not have the big gains that they will have later on in the 30 to 50, 60 years of their adoption period when they become commercially viable. But one of the big challenges, like two of the big challenges here that really are making it hard to identify the effects here, and which I think my paper can contribute to, is firstly that there's often very detailed data lacking. So when we think of IT capital, even though we're quite in a recent period, we still have very little kind of across-country evidence, geographic evidence on the adoption of these new technologies. They're very badly reported in a way because no one can expect that they will become important. And also there's a quite big heterogeneity problem, because you might think the areas that are the most successful, most developing, most dynamic, they are obviously the ones that will adopt new technologies early. And I think here I can really contribute with my data and also the empirical methodology I have. And really what I'm asking is three key empirical questions. Does the early adoption of new technologies lead to economic development? So basically just, even in the early period of adoption, where maybe only 5% of firms adopt the technology, is there an economic effect? And then from this, and the answer is yes for the first one, do these differences in economic activity persist? In the case of electricity, which I will look at, you have basically that some areas adopt electricity locally because they're restricted by geographic factors in the adoption. But then in the period afterwards, like from year 20 of the first adoption to year 50, the access to electricity spreads quickly with the extension of the electricity grid, and basically there's universal access to electricity. So here's really the question: can differences that emerge in these first 20 years persist? And then the third question is, why do these persist? So what's the mechanism that can explain this, even though everyone gets access to electricity? And I investigate these three questions basically in the historical setting of Switzerland between 1880 and 1900 in the adoption of electricity. And that's really the first 20 years of adoption. And I exploit very detailed geographical variation here in the adoption of electricity and also the potential. So I have very nice data that I can use for which locations can even only adopt electricity in this case, because all the electricity adoption depended on water power at that time. Yes? Sorry, I wasn't sure if that was a question or not.
Well, maybe just background noise. So
yes.
Please go
on. So the historical setting is basically Switzerland between 1880 and 1900. It's a country at the forefront of electricity adoption. So it's really one of the main adopters. It's on the same parity with the US, which is always seen as this kind of technological leader. Crucial here, again, is that the adoption is quasi-random, which gives me some variation that I can use to instrument the actual adoption to deal with kind of homogeneity concerns. And then there's this rapid expansion of the electricity grid after 1900. And you can kind of see here the key data that I'm using, and the colors of the areas are basically the actual electricity generation that is observed by 1900, and that's also what is used because there's just not the transmission technology to use electricity in areas far away from where it's generated. You can also see the black dots in their shape basically represent a map of engineers at the time where they basically plan the optimal location of power plants and what's the maximum generation across the whole of Switzerland as one unit in terms of electricity. And you can see that really this plan very well predicts where actually the adoption has happened as well. And then finally, you can see kind of major rivers in Switzerland, lakes, and also towns, which are the kind of red houses here. And really what seems to be the case is that what drives electricity adoption is not kind of predetermined economic factors, and I will show you some more evidence here, but it's these natural locations that make it possible to adopt electricity in Switzerland. And what I find is that the earlier electricity adoption led to economic development, and really between 1880 and 1900, a 1 standard deviation higher exposure to electricity led to a 3% increase in manufacturing employment. So it's quite a big effect actually, and it's quite a key driver of structural transformation at the time. And I also see that this effect on structural transformation, in particular on industries, and also income per capita persists up to today. So these areas that adopted electricity early for just a very short period of 20 years, these are now richer and more developed still. And the mechanism that I will kind of highlight is that it's not the technology itself. So you could think that these areas just use more electricity, so they have like some better experience with kind of exploiting this technology, but this doesn't seem the case. So as the electricity grid expands, I also see that differences in electricity use really disappear across areas that adopted early and those that adopt later. But rather what's happening is that this initial exposure to a new technology drives new human capital accumulation. There I have evidence on both that there's an increase in the supply of education locally, but also a demand side effect. So there's really there's new opportunities arriving in these areas and people take them up, and there's human capital formulation in local areas that were exposed to electricity. And this then translates to innovation, which is then the driver of this long-run effect in terms of industrialization and economic development. There's 3 literatures. One is basically on the effect of electrification during the 20th century. I here contribute that I really am the first paper that looks at the first stage of electricity adoption. So I'm basically moving from everything else, which usually look at the spread of electricity grids into rural areas. I move into kind of a setting where actually cities and urban areas also adopt electricity for the first time. So here the key contribution is being able to look at the kind of first mover effect. I contribute to kind of a literature that looks at the effect of technologies on human capital accumulation, and also to a literature which kind of looks at what's the long run effect of technology adoption. And here, what's the key difference is again, that these papers usually look at how many steam engines, how much electricity was adopted at the height of their importance. So like usually 50, 60, even 100 years after their first commercial introduction, what are the areas that adopted most? And here, one of the problems is that you usually have that there's a lot of capital investment into these technologies. So it's not the early adopters we're looking at, but rather the ones that are very intensive in the technology. And these papers usually find actually a negative effect of investing heavily into one technology. So I think I'm here the first paper which really shows that adopting a new technology early can actually lead to very long-run beneficial effects. I will go through the paper as follows. I will give you a very short historical context. I will actually focus on just one example, which I think tells the story that I observe empirically across the whole of Switzerland really well. But feel free to ask kind of like questions about the more broad picture. Then I will go into the empirical approach, discuss the data sources, go through the results, and then kind of draw a quick conclusion. So I think what illustrates what I observe here really well is the case of kind of a firm in Switzerland, which is called LONZA. And the name actually of this firm comes from the local river that was used for their electricity generation. And it was basically a firm which was set up in a very small municipality with like a population of just 400 people. It was kind of targeted at generating electricity when it became available to kind of supply the local area, but it also was very heavily invested into producing new chemicals, and in particular calcium carbide, and that's produced by kind of having an oven, which is very heated to a very high temperature, which is only possible with electricity. So it's kind of very invested into these new kind of technologies that get developed. And what basically happens is that this firm is somewhat successful. It kind of expands, and even though there's setbacks like calcium carbide it kind of has a drop in prices as more and more firms adopt it. It kind of develops new products, it moves into new areas. It also opens a new plant 10 kilometers away. And this firm really succeeds in kind of persisting over time and kind of developed into one of the largest companies in the world. So it's like in the top 50 of chemical companies in the world. It has more than 14,000 employees. And a large share of these employees are still located in the kind of location they opened later. And that explains basically 50% of, the employment is basically 50% of the population today. There's large commuting into this relatively small town where they moved. So it's a very big success story. And what seems to be the case is actually that there's a lot of local education going on. So these chemical firms, they needed workers that were able to do new processes, which were able to drive innovation. So they actually established usually their own kind of schools with the municipalities where you could have some vocational training and also some theoretical training. And there's quite big success story. For example, one is Paul Hermann Müller, which is one of the few Nobel laureates in Switzerland, and he went through the LONZA schooling program. And when you look at his actual Nobel webpage, there's actually a mention to LONZA, and that this is one of the key kind of steps in his career. After dropping out of school, he went to LONZA. He got this very good chemical education, and that really made it possible that he continued his career. So there's really this education channel, which is quite crucial, which then translates into innovation. And this seems to be even persisting as the original plans, the original firms might move away, because the site in Gampel actually closed in 1964. So the chemical production plant was closed, but what can be seen is that the population still is extremely high skilled. So 4.7% of the population in a town, like in a small village town, which has now 1,000 inhabitants, are scientists. And this kind of share is nearly as high as Basel, Zurich, like the big cities of Switzerland. So there's really this local boost, even in rural areas, in terms of kind of human capital accumulation and innovation, which is then also successful in persisting over time, even if there's quite large shocks afterwards. And this is basically also what I'm kind of documenting now empirically. And I think I have a relatively nice empirical setting, which is very clean and can account for a lot of factors. So this is basically my short-run regression equation, and I will then later extend that to kind of also cover the long run. So in the short run, it's basically, I look at the difference on the left-hand side in measures of development, like for example, the agricultural share, manufacturing share, services share, to kind of catch a structural transformation for District D across Switzerland between 1880 and 1900. And I regress that on the adoption of electricity. So in this case, it's basically the generation as well as the use of electricity, because all the generated electricity needed to be used locally. So this already, as you can see, kind of accounts for like fixed differences between areas. But then what I do additionally is I control for a set of factors that are predetermined. For example, geographic factors like altitude, longitude, latitude, but also economic factors like population density, agricultural share, education level, pre-existing water mills, and also kind of trends across like main areas of Switzerland. So this basically captures kind of differential trends controlling for these initial factors. that might also influence this development in this period. This, of course, might not be sufficient. So a key problem is that electrification and the kind of adoption of a new technology is not random. And there might be other factors which are unobserved. So I think the most straightforward one that everyone thinks of is usually an upward bias, where you have high demand for electricity in areas that are industrializing fast in any case. But what I actually see in the empirical part, and what also seems to be very well supported by the historical sources, is a kind of downward bias in this case. And that's that areas which have the highest demand for electricity, there's a lot of constraints on building these water power plants. And one of the key ones here is that there's already water concessions allocated. So actually in the places where you have the largest marginal gains, like for example, Basel, where there's already a chemical industry established by 1880, you actually see that there's very little adoption of electricity. There's simply not the possibility to build electric power plants that are large and generate a lot of electricity, because there's already stakeholders that kind of block these developments because they have their own little plots of water concession that they use for their own kind of production and other things. And this creates a downward bias for actually areas that adopt are the ones that are kind of developing less quickly. And to kind of deal with these two issues, I instrument the change in electricity produced per person with the log water power potential per person. And this kind of information comes from a survey of engineers in Switzerland at the time, which kind of try to kind of plan the optimal location of all water power plants, independent of kind of existing development, or they disregard also the economic viability. And actually, they maximize the energy in part, and that's their main focus, because it's very hard for them to measure the existing development and the economic viability. So for simplicity, actually, and for my benefit, they only focus on what would be the maximized energy considering the natural features that are available. And these natural features are usually very small and otherwise insignificant. So most of the locations are actually on small rivers, like very small streams, and not the large rivers of Switzerland, not the Rhine, the Rhone, the Aar, but really at local features and a combination of things like how steep is the river combined with if there's a confluence of rivers or a turn in the river shape, which makes it perfect to place a water power plant, a pressure pipe, and these kind of things. And what's obviously crucial for the exclusion restriction is that there's no other use for this water power potential. So there's no effect from this water power potential on economic development other than through electricity generation at the time. And you can see on the left-hand side the first stage. So this is basically the first stage without dividing by population. It gives you the water power potential. It gives you the electricity generated from water in 1900. And you can see that districts which have a higher potential are those that also will generate more electricity. Well, on the other hand, these kind of features were not even relevant to generate electricity from water without the possibility to use electricity. So this is basically the pre-existing water mills that kind of use mechanical transmission. So you can think of the wooden wheels, the shafts, the belts that kind of are very common for making flour, sewing mills at the time that often exist since the Middle Ages. And because these kind of, the technology of transmission was very much struggling to transmit a lot of power. So the shafts might break, the ropes might break if you exploit too much power. These were not able to actually exploit the full water power potential. And you can see that here that basically only due to electricity and its availability, there's this increase in power being exploited. And water mills were really placed for other reasons at other locations, and they could basically be built nearly everywhere across Switzerland because they didn't need the same features. And I can also show you that the allocation is non-random in other kind of economic characteristics, as well as there won't be any pretrends. I'm happy to wait for questions. I just see that there's some in the chat, but I can't really get to the chat feature. So if you have any questions, please just ask now. Maybe.
No, it's just for internal purposes, we need to list ourselves in the chat, so the messages are just people writing their names and affiliation. I will let you know if I see any questions in the chat, but it seems that so far so good.
Thank you very much. So yeah, and here you have basically the random allocation. You can see that it's very much randomly allocated across Switzerland in terms of geographic, so per square kilometer, there's the same potential usually available like for different population densities in 1880, as well as kind of different agricultural manufacturing services shares, by the mechanical feature that if it's randomly distributed by geography, you will have less potential in areas with a higher population density, which you see, but as soon as I control for large differences in geography, this also becomes as good as randomly distributed. So electricity really is randomly assigned to areas. And then again, I also difference the effect and I control for differential trend, which accounts for a lot of factors here.
Sorry,
now
one quick question.
Yeah.
So you said that unit of observation is like a district?
Yeah.
And how big or how small can be districts in Switzerland? I'm really not familiar with the sizes.
So districts are probably usually about like 20 square kilometers, I would say, and I have about 178. So they're relatively small units of observation, but I think what's quite important is they reflect local labor markets in Switzerland for quite a long period of my sample. So until the 1950s and the construction of the highway network, they're basically very independent economic areas. You have railways that transport goods, but you have very little commuting going on. So in the long run, I basically use my initial strategy, and I look still at the early adoption on economic development up to point T now. So between 1880 and, for example, 1950, 2010. And I run all these regressions separately. So they're all individual regressions. It would be very similar to kind of event study design where I would interact the initial controls with time-fixed effects. But what I do additionally, and this is quite crucial here because the instrument might determine later buildings of water power plants, even 1900, I control for any water power plants that are built after 1900. And in this case, this doesn't reflect a bad control because we have that the electricity grid spreads. So after 1900, all the water power plants that are built are basically kind of centrally located by the state. So they're no longer related to economic characteristics locally, but you basically build them where they're both best suited. So this basically accounts for any later effects, and I can see very well that these expansions just increase employment in electricity supply and electricity generation. So it really just accounts for a bit of an upward bias that I would otherwise observe. So I have about 50 minutes, I think. So I should just go quickly through the data. So what I have is a very nice...
You're doing fine. Yeah, you have
lots
of time. So take your time, please.
Thank you. So I have very nice historical data, and this comes basically from a 5-volume book of electricity adoption and the potential of electricity that was kind of organized by the Swiss Interior Ministry to kind of examine how much water power potential Switzerland had. So they put a lot of emphasis on this new technology because they had no coal. So this was like their natural resource that they wanted to exploit. And what this survey does, it has very detailed tables and maps on building and extension dates of all water power plants, not just electrical ones, the energy produced of these water power plants, information on the type of energy used. So for example, is it electrical power plant? Is it a mechanical transmission power plant? But also it kind of gives you industry data, which industries are kind of producing this electricity. And then it maps a table kind of summary into also the geographical distribution of all these existing power plants, but also a map of potential water power plants. So what would be the optimal network of connecting water power plants to pressure pipes to generate the most electricity across the whole of Switzerland? And I matched this very detailed data on the adoption of technology here to sectoral employment across 178 Swiss districts, which comes from the census from 1860 and 2011. And that will be basically my main measure of economic development. It's basically structural transformation. So you move out of agriculture into more productive industries like manufacturing and services, which also have higher productivity growth. And then I combine this with a lot of additional sources like education levels from the Swiss military exams, electricity used from industrial censuses, and a lot of other kind of data that I have. And you will see that quite well when I talk about the mechanisms, what kind of data sources those are.
Can I clarify a question here, please?
Yes, sure.
So am I correct that your dependent variable development is the share of the employed people, let's say in agriculture, or the share of employed people in the manufacture?
Yes,
right?
exactly.
So it's not output, it's not, let's say, euro or dollars or whatever.
No, so it's the main variable is the share of employment. So it's basically structural transformation. Mm-hmm. I have output data at a more aggregated level than the district, and I say very similar effects. So it's not just that there's a structural transformation, but it translates into higher output in this case. But it's very rare that you measure output so far back in a very detailed way. So I had to focus mostly on employment, which is much better recorded, and I think it's also more trustable data in this case. So now I'm going to discuss the short-run results. So this is basically the effect of electricity adoption between 1880 and 1900 per person on the agricultural employment share. And this is the OLS specification. You see a negative effect, which basically means that for each 1 kilowatt increase per person in electricity generation, the agricultural employment share declines by 29.1 percentage points. That seems quite large, but we're at a very early phase of adoption. So the average adoption is only 0.02 kilowatt per person. And I have kind of clustered areas at the cantonal level, which is quite an important political area, as well as kind of spatially clustered areas, and they seem very similar. And I use the cantonal ones throughout because they seem a bit more conservative when we look at the baseline specification. And then what I do is I kind of control for geographic factors like altitude, longitude, latitude, and whether they lead to differential development between 1880 and 1900, economic controls, mechanical water mills, so pre-existing use of water power, and also region fixed effects for like major economic areas, which correspond very much to cantons, but in some cases aggregate some cantons. And I have basically 178 observations, and the coefficient is relatively robust. So I see the same effect over all these specifications. The average district basically has that the increase in electricity adoption led to a 0.5 percentage point decline in agricultural employment. When kind of looking at my V strategy, so here I instrument the actual adoption of electricity with the initial potential, I see that the effect increases and it roughly doubles in size. And this is again in line with this kind of observation that was also noted by engineers, that it's really hard to kind of build water power plants in the most successful and most developing areas across Switzerland that had the most to gain as well. Both the first stage estimate and the reduced forms go exactly in the direction I would want. So areas that have more potential adopt more electricity, and also the potential directly predicts a decline in agricultural employment. This transition out of agriculture, at least initially in the short run, is mostly from agriculture into manufacturing, while there's only a very, very limited effect on services in this case. So I will turn out to the long run, and basically each of these coefficient estimates reflects the effect of the initial adoption of electricity between 1880 and 1900 on the time period 1880 to 1900. So this would be basically the IAV estimate that I just showed you from panel B, the same for panel C and for panel D. Before that, there's basically a pre-trend. So that's basically what is the predicted economic development between 1816 and 1818 from the later electricity adoption. You can see that actually the pre-trend, even if it would be significant, it would go in the opposite direction. So actually areas that have the highest potential were, if at all, falling behind in terms of economic development. So in the long run, you can see that the effect actually increases. So there's a further decline in agricultural employment, which then kind of recovers a bit, and there seems to be a bit of convergence after 1950. But the sectors that gained here, it's really manufacturing, and the manufacturing effect is really persistent. So there's a very long-lasting effect on manufacturing employment up to today from this early adoption of electricity. And this is after controlling for any further extension of electricity generation. And basically, when we look at 2011, the average district basically has about a 2% higher industrial share than a comparable district. And this is quite important. I think that's maybe less known. So when we think of like the US or the UK. Manufacturing is really seen as this kind of low productivity sector sometimes, and we want people to move into services. But manufacturing here is really high productivity, and the wages in manufacturing are actually higher than in services. Like you have chemical companies, pharmaceutical companies, and they pay at the same level as the banking sector in Switzerland. So this is actually high productivity employment that creates a lot of wealth in this case. What can also be seen is that there's a temporary increase in services, but then it kind of converges. And this really, this seems to be in line with some evidence that it's easier to move out of agriculture into services, even if you're lagging behind. Or another explanation is that as we kind of have all this agricultural labor moving out, manufacturing is so productive that people stay in that, but there's basically some move into services in these areas that have not developed before. And also there's a lot of movement after 1915 and kind of the building of the motorway network out of agriculture into the cities and urban areas. So it's actually what we see here is not necessarily convergence in per capita terms. Like we see convergence in per capita terms, but when we look at the level and the growth rates, we actually see that the areas that seem to be kind of catching up, that adopted electricity later, they're actually not converging, they're actually further declining. They're basically just losing population. And here's basically the result in terms of value added. This is at the cantonal level, so there's less observations in terms of the n dimension, but I have much more observations in the t dimensions. That you can also see that here really we have that areas that adopted electricity early are continuously having a higher level of GDP even by today. So it really increased output as well, not just structural transformation. And now using kind of current outcomes, not the difference setting, but I can also see that districts still have higher average and median incomes. So really, even though we have an advanced country, there's large spillovers, there's very good infrastructure, which would kind of attenuate the effects that you would expect to find here from the early adoption. There's a very persistent and very important effect. So this basically, the average exposure to electricity is about associated with 3 to 5% higher income today for these districts. And it also spills over in education, which is usually a very large determinant of these higher incomes. And I will talk about education in the mechanism section as well, because this seems to be the key mechanism why these effects persist. So when we think about mechanisms, I think there's some that come to mind immediately, which is, for example, that these differences in economic development persist because places still use more electricity that adopted it early. That would be one of the mechanisms that I tackle, and that doesn't seem to be the case. Another one might be agglomeration forces. So you might think that there's a lot of population that moves into these areas, and that's why they have a larger population, they have kind of economies of scale, and that's why industries persist in this location because of these economies of scales. And again, this doesn't seem to be the case. So there seems to be very little migration initially in Switzerland, and there doesn't seem to be immediate population growth. Instead, what seems to be, what I find the main mechanism is that there's an immediate increase in the educational level. So especially at kind of the high elite level of education, and that's secondary education in Switzerland. So math scores go up, general knowledge scores go up, and this is very complementary to these newly developing chemical industry jobs. And I will show you in a second that there is this effect on chemical industries. And then this human capital accumulation seems to be by the setting up of dual education institutions, by more people enrolling into dual education institutions, and also there being more demand for education. And also finally, there's more innovation now in these areas. And one thinks, even though the initial exposure to electricity is very random, so a lot of like initially rural areas get like exposed to this positive shock. There's this adjustment in infrastructure. So the specialization is actually, I think, very much helped by getting connected to kind of the rest of Switzerland, but also the rest of Europe, which kind of allows you to produce very specialized chemicals, very specialized products, because you can export these goods to other markets, as well as kind of exchange ideas. And I think here, this is kind of a complementary mechanism, but it's quite important to have this adjustment in infrastructure, which makes it possible to be so specialized. I think what's quite interesting to start with is kind of to look which are the sectors in manufacturing industries that actually drive the persistent effect. And I kind of grouped it in two broad groups. There's generation and kind of mixed. So these are kind of sectors which gain from the generation of electricity. So it's basically employment in the kind of water power plants, generating the electricity, but also supplying it, as well as kind of construction, which builds these water power plants, and also kind of machinery industries, which might supply the turbines. And what you can see is that there's this large effect on construction initially. So one of the key factors is that there is an increase in employment in construction, which is really due to this building of new power plants. But this effect basically disappears. And even though the effect on generation persists over time, it's relatively small compared to the overall effect of manufacturing. It's like about 10%. Instead, what seems to be the main driver of growth is chemical industries. So we see immediately effect that areas that get electricity increase employment in chemical industries, and this really persists over time and grows over time. So these are really one of the group of industries which are successful. One interesting feature is though that it's not just chemical industries which are quite novel and newly developing, but also kind of textile industries are more successful in the long run. So it seems like these areas which are exposed to electricity, they have then textile industries, which were usually established already by the 1900s, that survived even though international competition increased. So these were more innovative firms then, because if you look at textile industries today in Switzerland, they're really very innovative firms. So they produce textiles for cars, airplanes, pharmaceutical textiles. So it's really not this low value sector that we usually associate with textile industries from the Industrial Revolution, but it's really like highly innovative firms, which explains why they can survive even in this high wage Swiss environment and with lots of kind of international competition. And what's kind of interesting to kind of when looking at this chemical employment, this is actually quite a huge effect. So chemical employment in Switzerland is relatively small, even though it accounts for about 30% of Swiss exports. And what the early exposure to electricity kind of predicts is about 70% of the spatial location of chemical employment today. So it's quite a huge effect. So it's one of the key drivers of like, where are these very successful industries located across Switzerland? So this kind of very temporary shock that was kind of driven by very much the luck of being assigned a location that can generate electricity had a huge impact on the kind of spatial development across Switzerland in terms of this industry. I think that's quite important when we think of like income differences across advanced countries today and what might be the historical factors that drive it. Another mechanism that I basically rule out is that as the electricity grid expands, we really see that there's no longer any differences in electricity use. So per employee in industry, but also in services and manufacturing overall, there's no differences in kilowatt by 1929 and 1955. So there's basically no differences in the intensity of the technology itself and its usage. Similar, there's very little population growth, so there's no agglomeration effects in terms of in-migration or even local kind of increases in fertility. So this seems to rule out some very common mechanisms that were documented for the US. And in the US, obviously, the kind of setting is very different. You have a lot of migration, you have very long distances, which might change the pattern of development quite a lot. And then looking at human capital, and I think this is kind of my first kind of main evidence of this increase in human capital accumulation. I have here kind of military test scores, which were kind of mandatory for all the male population at the age of 19. And they basically structure their questions in a way where they ask 5 different questions, but they get kind of harder with each of the questions. And if you fail the first 2 questions, you're basically at an education level which is below primary schooling. And then if you reach the best question, you're basically at the level of finishing secondary education. And these questions... Yes.
I'm sorry to interrupt you. 10 minutes, please.
Okay, thanks. Perfect.
All right, thanks.
So basically, we can see different kind of outcomes, and we also see the effect from 1818 to 1900, 1818 to 1910 for secondary education and for primary education. And really, where there's the largest effect on human capital accumulation is in math and general knowledge at the secondary level. So that's really like kind of elite education. So those are really high skills at the time that are also crucial to kind of drive further innovation. And this kind of human capital accumulation really was helped by the dual education system. So when looking at kind of population centers and those that are very exposed to electricity at the time, there's a clear rise in the number of students, in particular in the secondary level of vocational schools. We see an increase in students, but also in schools. So schools seem to increase. Well, for polytechnic universities, which is kind of the tertiary level of dual education, there's not yet an effect on students. But what seems to happen is actually that these tertiary education institutions open a lot of new departments. So this is not just the number of kind of polytechnic universities, but rather the number of departments in polytechnic universities. And I can see that there's a lot of new chemical departments opening, mechanical engineering, electrical engineering. So these kind of institutions seem to diversify into new areas, not yet with an effect on actually the number of students, but there seems this change in the formation of human capital, the provision of education that's happening, which then is crucial for the long run effect. Similarly, you see here, this is data from Swiss referendums, where basically individuals vote on should overall the central government spend more on education and innovation policies. And you can see that already by 1992, there's a clear increase in the support for these policies in areas that are more exposed to electricity. So it's not just that there's more supply locally of education, but also the local population sees there's new opportunities, and to take advantage of these new opportunities, they require more education. So they're more in favor of educational policies here, which kind of complements the overall development. So there seems to really be maybe a big push story where there's really this increase in kind of education and human capital accumulation, which then finally translates into patents. So overall, these districts have more patents. Have more patents now per person. This occurs before 2000. There's still more patenting going on after 2000. So they're still more innovative than a comparable district without the early adoption of electricity. And what's interesting is that most of this increase in kind of scientific research and kind of development is actually occurring in rural areas. So the areas that gained the most in terms of this kind of capital accumulation are actually more remote areas that have gained in terms of developing more. And to kind of make sense of this rather unconventional findings, so usually we think that towns and cities are really what drive innovation. I see that there's an adjustment in the infrastructure network. So these areas get better connected so they can participate in the kind of knowledge economy, but also export their goods, import their raw materials. So you can see there's more operation points, so more on and offloading happening in areas exposed to more electricity initially. There's more tunnels, so more infrastructure investment. So that's the main spending in Switzerland. So there was more invested into infrastructure, and there's more traveling. So there's more people traveling into these districts and out of these districts at the time. So yes, so to summarize basically for the mechanism side, I see that there's three main unsupported mechanisms, which is that persistent differences in the use of electricity are the driver of this long run effect. Electricity generation itself doesn't seem to be the main factor in explaining these long run differences that occurred due to early adoption. And also agglomeration forces seem not to be a key kind of driver here. But instead, the main mechanism that explains the long run effect is basically human capital formation and innovation. And I think when we look at kind of the environment in Central Europe, this very much reflects a lot of the development that occurred, which is very different from the US. Indeed, like in Germany, in Austria, in Northern Italy, you see a lot of very specialized firms in smaller towns and villages, which are very successful in manufacturing goods that are in high demand worldwide. And this seems to be potentially be related to kind of initial geographic advantage that these areas had, and the kind of formation of local human capital, which is very specialized with regards to the industries that are successful. And that seems to be an interesting difference compared to kind of evidence on the development in the United States. where usually a lot of the long run effects come from population agglomeration or by kind of clustering in certain areas. So the success of specific towns and the formation of large towns that are the kind of key driver of development. And I think kind of keeping these nuances in mind might be also quite relevant when we think of economic development in countries like India and China that are now catching up. So here we have quite high population density. We have a very different setting than the US, where there's very little immigration initially, where there's very little kind of transport costs. So in the US, you might think you only have to focus on the towns and lead to like foster development in towns. But when looking at the Swiss setting, you can actually try to push also the kind of more rural areas. So you can have a more like wholesome development policy that's not just driven by a few cities that drive the success here. Indeed, it seems like if you give people opportunities in rural or urban areas, they will both react to it and take that advantage. And this will drive further knowledge accumulation and success in this case. Yes, just to summarize the main contributions of my papers, I find that the early adoption of electricity in the 19th century led to increased industrialization and an increase in incomes. And this economic effect of early adoption persists and increased up to today. And this is despite the access to electricity itself becoming universal across Switzerland. And the main mechanism here, I think, is really human capital accumulation and innovation. And thank you very much for listening. I hope you have any questions.
Excellent. Thanks very much, Björn.
Thank you.
Questions, please. Questions, comments? Andrei?
Yes, actually, I have a question. So can you switch to the slide 30, please?
Sure. Here? Yes?
30.
That should be it. What was on it?
This one.
Oh.
So what I do not understand is the difference between all districts and population center. What do you mean by all districts and population center here? So because you discussed the right one, but not the left one.
Yes. So basically, all districts are basically my whole sample, but there's a lot of very small areas where you have maybe only 1,000 people, 500 people living in these districts. And it's very unfeasible to open a school there because there's just not enough demand for it. And what's common in Switzerland at the time is that if you're in the small areas, you actually commute for 3 months to population centers to get your education. So I don't see much of an effect here, simply because in the kind of smaller areas, the less populated ones, there's very little development in terms of education, even if you're exposed to electricity. But when only looking at the kind of larger areas, and I think this is kind of all the districts that have more than 10,000 inhabitants, you really see that there's an effect. So where it seems reasonable to open a school, that's actually what occurs when you're exposed to electricity. So that's basically what I'm doing here. So I didn't have enough time to go too much into the details, but I think it seems consistent with the historical framework that there's only an effect in population centers on kind of increasing institutions.
Are these population centers are still rural areas, or these already towns and cities? Because
so they're somewhat rural. So the population size is that, so they have some smaller towns. So they're not completely rural. So they're not just agriculture, not just villages, but they have like a small, like a town center in a sense. That doesn't necessarily mean that they're mostly urban, but they are more broadly, they have some kind of population center where you have like already potentially education institutions, where you have some administrative center and so on.
Thank you.
Bernardo, you had a question, I guess?
Yes, I have a couple. So the first one, I mean, I know that your study is like very innovative in some senses, but let's say like thinking about like some closer studies to this, like, do you see like similar patterns in other countries? If there's anything remotely close to what you do, that would be my first question.
I think maybe the most related paper might be quite recently by Dell and Olken. So it's like a 2020 econometrica paper. They actually look at kind of So they look at like a colonial kind of policy. So they have a very kind of different setting in mind, but they look basically at kind of sugar plantations in Dutch India. And what happens is basically that the Dutch set up sugar factories, but in contrast to usually very exploitative institutions, you needed to actually set up the kind of sugarcane production. You needed to set up the infrastructure network to transport it to the sugar plantations. You needed to educate the kind of local workforce to kind of work in these plantations as well as in the factories, because it was quite new skills required. And they really see that there's a long run effect, and that there's really this long run effect also due to the human capital accumulation and also due to the changes in the infrastructure network. So they basically see that there can be this kind of gains from industrialization in this case. And I think that's in some ways relatively closely related. Then when looking at technology, like there's Audit Galore and Raphael Frank, which look at France and the adoption of steam engine, they actually see that those areas are declining in the long run. But they really look at like very intensively adopting areas, and that's mostly textile industries that have very heavily invested into particular types of spinning jennies and so on. So here it's very about one industry and their decline. So I think that are kind of the two main papers which might be similar in the kind of narratives that they find.
Okay, thanks. My second question is like, well, as we both very well know, like trains are quite awful in the UK. One of the reasons that the people claim is that, well, the UK was among the first countries to like start the railways, and since they didn't suffer that much damage during the World War, like basically like they kind of got stuck with this old infrastructure compared to like more modern railways that you see in Europe. So I was wondering if like maybe depending on the technology, if you are the first one to adopt it, and then if you see yourself kind of stuck in this old technology, it might be harmful in the long run. But I don't know if you have read of any such cases with more hard evidence than this anecdotal case that I'm saying here.
Yes, so I think one there's a big literature like theoretically in macro on like vintage capital, and one benefit here, so it is that electricity doesn't have this factor. So you basically get connected to electricity and you can use it in a variety of ways. You can use different machinery and so on. But what this human capital literature argues, and I think that's very related to steam engines and a lot of other kind of production technologies that are adopted, is that you need to embody new technologies in a machine. So you have a machine that you invest in, you buy this capital, and then you can use this technology. And here it's very much the case that these technologies become obsolete, but you kind of are trapped with the technologies. Like, for example, I think in the UK, it's quite the case that they have a very small, narrow railway gauge, which makes things quite difficult. And you're basically stuck with this technology, which you have invested in, and now you can't get out of it. So there's definitely the case, and I'm in a way lucky that I can abstract from this problem, because electricity is different as a technology, much more comparable to now mobile phone networks, the internet, and so on. It's a quite a similar technology to what we have now in the 21st century, rather than kind of these very capital and intensive technologies.
Thanks.
Okay, thanks very much. Please, any further questions? Björn, I have a question, if I may. It's more about technology. Why is it so important to be close geographically to a power generation plant? Because electricity is relatively easy to transport, and all we need to do is to extend the cable not by 1 kilometer, but maybe by 10 kilometers. Does it make a big difference?
Yes. So I'm very lucky here in my setting, because so firstly, it's very related to water power, because there's no coal in Switzerland. It's very costly to import. But also initially, most power transmission is DC. So I can really see the distance of the extension line. So there's kind of documentations. And by 1900, the longest transmission line was 10 kilometers, and that was much longer than the others. But then over the next 5 years, there was this switch from DC transmission, which is very bad for transmitting electricity over long distances, to AC technology. And you have, for example, in the US, this kind of current war with Thomas Edison, Westinghouse. And this switch really enabled the long run transmission. And then with AC technology over 5 years, actually, the distance that that transmission lines had was from 10 kilometers to more than like 100 kilometers, 200 kilometers. So that's actually why it initially is very local, but then basically everyone gets access really quickly. So it's a very interesting historical setting, actually.
Okay. All right, yeah, that answers. Thanks. Please, any further questions, any further comments? May I ask another one, if I may? Can you observe any impact of early adoption of electricity on political preferences of people, how they vote? Are they more, you know, because you were able to establish relevance of early adoption of electricity for human capital and development. You could possibly argue that political preferences have also changed. You talked about referenda where people were asked about their attitude to education, but how about some other measures? Might be possible to find something.
Thanks. That's a really good question.
And voting data, of course, is very local, so it's easy to check.
So I looked at other referendums. So there's not just ones on education and infrastructure. There's some on like kind of the working of the state, kind of the institutional framework of like property rights and so on. And this doesn't seem to be affected much. So the attitudes on property rights seem to be staying the same. The worker right kind of things stay the same as well. But what I can see is that there is, when we look at party voting, it seems that it somewhat increases the share of voting for socialist parties. And socialist in the case of Switzerland is more actually parties that invest quite heavily into the education system. So one of the defining factors is that they want education more. They want to support unions and wage bargaining. So there seems to be this kind of shift to the left, but it might simply be because there's now more industrial employment compared to rural agricultural employment. But there seems to be something going on, but I've not looked into too much detail into it. I think it might be an interesting follow-up question. So it's a very interesting question indeed. Yeah.
Okay, thanks very much. Please, any further comments, questions?
Yes, I have one more question,
Right.
which is actually related to the same slide that you have here.
Mm-hmm.
So, okay, I need first like a pre-question and then I can go to my question. So the pre-question is like, how much heterogeneity in terms of population are among like the Swiss districts? Do you see like large variation in terms of population or not too much?
Yes, they're quite different in population size. So as said, some can have like 500 people, while others are like Basel, for example, they have like nearly 1 million at the time of Zurich. So it's quite different, like quite a lot of differences. They're more similar in terms of geographic size.
Okay, so now my the real question is like, which is related to, so like, okay, I get that if you look at districts, you don't see like an effect on like of electricity on schools, but if you look at population centers, then yes, like if let's say you look only like maybe at bigger districts or like basically like, do you see or can you see any kind of threshold in terms of population for electricity to have like meaningful impacts on educational or other outcomes? Like maybe if they adopt electricity in a small town with like 500 people, it doesn't make much of a difference. Or then if the town or the district is larger, then it does make a difference. Like, do you see this pattern?
So that I haven't looked at the precise threshold. So I know that for industrialization and the economic impact, the population size doesn't seem to be so important. It seems to be only related to kind of the educational institutions, which seems to be in part related to the historical setting. But I think you're right. It would be really interesting to know what's the kind of size where you see the effect starting of kind of forming educational institutions. I haven't done that, but I guess it must be somewhere below 10,000 and starting maybe at 5,000 or something, where you have enough people to kind of like fill up the classes. Yeah, that would be very interesting. Thank you. Yeah, I'll look into that.
Sorry, Leonid,
Well, yeah, I see that. Yes, I think that that's about it. if there are no further questions, no further comments, all I have to do is to thank Björn very much for a very interesting presentation. It was great to have you here. And Bernardo, conventionally, please make an announcement what's coming up next. I guess.
Yes. Well, I join Leonid in thanking you, Björn, for presenting for us. It was a very interesting paper. Yeah. Good luck in the job market process.
Oh, yes.
Yes, it will be very interesting.
Last but not least, I think it gives you good chances.
And next week we have Samin Aref from Max Planck Institute, and he will be presenting brain drain and brain gain in Russia, analyzing international mobility of researchers by discipline using Scopus bibliometric data from 1996 to 2020.